Let's balance the redox reaction for K2Cr2O7 plus HCl. This is potassium dichromate, and this is hydrochloric acid. We'll do this in acidic medium, and we'll use the ion-electron method, also known as the half reaction method. So the first thing we do with redox reactions, we write the oxidation numbers for each element. I've already done that. If you need help, there's a link at the end of this video to help you do that. Next, we're going to write the half reactions for each species of interest, and those are the ones whose oxidation numbers have changed. That'll look like this. We can see the chromium, each chromium atom goes from +6 to +3. So this is a smaller number here. This has been reduced, so this is our reduction. And then we have the chlorine going from -1 to 0, so this is being oxidized. This is our oxidation reaction. So now we want to balance the half reactions for the atoms. We can see we have 2 chromium here, just 1 here. We're going to put a 2 here, but we have a problem with the potassium. We don't have any potassium over here. Let's just put some KCl on this side. Think of it this way. All of these reactants are together in a beaker. They react, and then we end up with these products, and they're all together. So we can put some KCl with our chromium 3 chloride. That's fine. We'll need to put a 2 in front of the potassium, though, to balance that. Now we have 4 chlorines over here, but we don't have any chlorines over here. So we're going to need to add some HCl to this side. And we can. These are together. That's not a problem. We'll do that. And we have a total on this side, 2 times 3, that's 6 chlorines, plus 2 times 1, another 2. So we have 8 chlorine atoms. Let's put an 8 here. And we're not going to worry about the hydrogens or the oxygens right now. Down here, we have a chlorine, 2 chlorines. Let's put a 2 here. And we've balanced these atoms that we're interested in here. Now we can balance the oxygen atoms. Let's shrink this down some. So I have 7 oxygen atoms here, and I'm going to balance the oxygen by adding water. So I can add H2O over here. And I'll need to add 7 water molecules here. 7 times 1, 7 oxygens, 7 oxygens. That's all good. Down here we don't have oxygens, not a problem. So now let's balance the hydrogen atoms. I have 14 hydrogen here and 8 times 1, 8 here. So I'll add 6 hydrogen ions, and that'll balance the hydrogens. Down here, let's just add 2 hydrogen ions. That balances the hydrogens. So now we're going to balance the charge by adding electrons. Over here, we can just add 2 electrons. Here we have 6 positive charges here. These are all neutral. So let's add 6 electrons here, and we've balanced the charge. So that's fairly challenging to do. At this point, what we need to do is balance the overall charge. Think of it this way. These are all the reactants, and these are all the products. But we have 6 electrons here in the reactants and only 2 in the products. That's not balanced, and with redox, we want to balance the charge as well as the atoms. What I could do is I could multiply everything here by 3. 3 times the 2 electrons would give me 6 electrons, and that would balance this 6 electrons. So what I'll do is I'm going to add the half reactions up now and simplify. I'll take the reactants, these here, and 3 times this, and then I'll have the products, these here, and 3 times all of these. That'll look like this. At this point, we can simplify. We can see here in the reactants, we have 6 hydrogen ions. Again, in the products, we can get rid of those. We also have 6 electrons here and here. We can get rid of those. And we can add 8 HCl together with 6 HCl. That'll give us 14. And once we do that, we'll have the balanced redox reaction for K2Cr2O7 plus HCl, potassium dichromate and hydrochloric acid. I'm going to clean this up and put the hydrochloric acids together. We'll have our redox reaction. So these redox reactions are really tough to do. There's a lot of steps, and you can make mistakes at multiple points in the process. But when you're done, you can check your work. So if we look at charge, we balanced for charge. This is all neutral. This is all neutral. Charge is balanced. And if you count up each of these atoms, they'll be the same on both sides. So we balanced for charge and for the number of atoms. This is Dr. B with the balanced redox reaction for K2Cr2O7 plus HCl. Thanks for watching.